Hello viewers, welcome to the Champion Tutors Academy. So in this discussion, we're going to look at dimension analysis. We are going to solve this problem here that is on the board. So the question is that in the gas equation, P plus A over V squared multiplied by V minus P is equal to RT, where P is the pressure, V is the volume, R is the universal gas constant, and T is the temperature. What are the dimensions of A and B? So now what we're going to do is, for us to find the dimensions of A and B, we first need to know the dimensions for P, which is pressure, the dimensions for V, which is volume, and considering this part, R is a constant, so meaning it has no dimensions. So we first find the dimensions for pressure. Now we know that pressure is simply equal to force over area. So meaning that for us to find the dimensions for pressure, we can simply get them from the formula. Now what we know about force is that it has dimensions ml t to the power negative 2, and area has dimensions L squared, like that. So now this therefore means that the final answer for finding the dimensions for pressure is m L to the power negative 1 and T to the power negative 2, like that. Okay, then coming to volume, we'll do that. Okay, coming to volume, we know that volume is equal to L to the power 3. So this implies that this is a dimension for volume. Now, since we found the dimensions for pressure and for volume, we can then come to finding the dimensions for A and B. So because of space, I'm simply going to write this information on this part. Now, there's a statement that you know that we can only add and subtract physical quantities with the same dimensions. Now if you see an equation where some physical quantities are being added or subtracted, just bear in mind that those physical quantities, they have the same dimensions. Now looking at the equation that we have, since pressure is adding this that is here, this therefore means that the dimensions for pressure and A over V squared are the same. And also, since V minus B is subtracting, this therefore means that the dimensions for V is the same as the dimensions for what? For B. So we can now write this as this therefore means that the dimensions for P, which is pressure, are the same as the dimensions for A over V squared. Now, this means that since our main interest is to find A, so we're simply going to make it the subject of the formula. Now, this will therefore mean that the dimensions for A will simply be equal to the product of the dimensions for pressure and let me just put it together, for pressure and volume squared. Now, it will therefore give us the dimensions for A to be equal to our pressure is what we have here, so which is m L to the power negative 1 T to the power negative 2 multiplied by the dimensions of V, which is L to the power 3. Now this one is squared. Okay, like that. Now this will therefore mean that our dimensions for A will simply be equal to, now this will give us L to the power 6. Now when it is multiplied by this one, we're simply going to get the dimensions for A to be ml to the power 5 T to the power negative 2. So we found the dimensions for A to be this. Now since we know the dimensions for A, we then go to finding the dimensions for B. So because of lacking of enough space, I'm going to clear off this. So adhering to the statement that we are trying to say, you can only add and subtract physical quantities with the same dimension. So this therefore means that the dimensions for V are the same as the dimensions of B. So we know that the dimensions of V are simply the same as the dimensions of B, since these two physical quantities can be subtracted. Now we know to say the dimensions for V are, so we know that, but V is simply equal to L to the power 3. So this implies that the dimensions of B, since it is equal to the dimensions of V, therefore means that dimensions of B is L to the power 3. Now we can then conclude by saying that the dimensions for A simply equal to mL to the power 5 t to the power negative 2, like that. And for B, we have that for B is L to the power 3. So now, this is how you get to find the dimensions for A and the dimensions of B from this gas equation. Thank you very much for watching this video.